This is the 14B video. Today we're going to understand inverse square law, understand Coulomb's law, and understand electric potential. Big question is, how do faucets and skyscrapers work? So remember, there are two codes in each video. One is a written, one is a verbal code. Each code will be 3 numbers randomly. You will not be able to guess them. Now, when you're taking notes, write what's in green. You will need these in your notebooks. So this is the 14B written code. I would recommend you write this down somewhere. All right, so the first thing we're going to do is we're going to open up with the Coulomb's law simulation. Then that'll help us answer, how does distance affect force in the inverse square law? So the inverse square law is a law that many phenomena follow, like light, sound, spray paint, gravity, electromagnetic force. But that to recall back to a video that'll be posted in the links also on these slides. Now notice how the variable r cannot be 0 because the intensity would be infinite. And also notice how the distance could never be large enough to make the intensity 0. So this phenomenon is used to measure distances between stars in the galaxy, and I provided a video link for that as well. So let's talk about the original question, what is Coulomb's law? Well, the electromagnetic force can be calculated with an equation called Coulomb's law. Coulomb's law follows the inverse square law. So the variables in Coulomb's law are Q1 and Q2 are charges, so they can be positive or negative, just like in the graphic off to the right. D or R, sometimes it's written as either or, is the distance between the charges, and K is Coulomb's force constant. So let's talk about electric potential, right? So we know about gravitational potential energy. So if I have 3 bricks at 1 meter and 1 brick at 2 meters, you'll probably say that, yes, the bricks on the left have more gravitational potential energy than the bricks on the right. But will the bricks on the left fall upward towards the bricks on the right because it has more energy? Well, no, the 3 bricks don't fall upward towards the single bricks because it has more energy than the single brick. The brick falls from a position of higher potential energy to a position of lower potential energy. That's how siphons work. So the reservoir must be at a lower position than the source reservoir, right? So the one that's being, the discharge reservoir must be at a lower position than source reservoir. You must have the tube filled with water to start that siphon. Water towers work similar to the way siphons. Water flows from a high gravitational potential energy to low gravitational potential energy. So if you see those water towers around town, which what it is, those are filled with water. They pump water up there. They have to use energy to give it that gravitational potential energy. But that's why if you turn on the faucet, like if the power's out, the water will still flow because it's using that gravitational potential energy. So similar to gravitational potential energy, electric charge flows the same way. It will flow from high electrical potential to low electrical potential, and 2 conditions must be met for the flow of electrical current. There must be a difference in electrical potential. There must be a conducting path. Electricity flow is similar to fluid flow. So voltage is the difference in electrical potential, or the cause. It's similar to water pressure. And current is the flow of the electric charge, so the effect. And it's similar to the flow rate in like that water simulation I had there. So those are the links for today, and I'll give you the code. 14B verbal code is 198. I say that again, the verbal code is 198. And once again, I'll leave you with this final thought. There's too much unknown in the universe to take a break from learning. Get out there and question everything.